In this class, we are going to solve some more examples based upon electrical engineering. Here we consider a network. In this network, we have to find out the maximum power transfer across a load and the value of that load. Let me consider this across this network. The load is RL, that is RL for the maximum power transfer theorem. Now, by the definition, we know RL must equal to RTH, and therefore, first of all, we have to find out RTH of this network. And in order to find out RTH of this network, we have to follow the concept of Thevenin's theorem. However, the Thevenin's theorem cannot be applied straight away in this case because we are having a dependent source. Therefore, the concept of Thevenin's theorem is to be applied by using open circuit and short circuit process. Now, in this case, let me consider the network which is open circuited across terminal A and B. This is 2 ohm, this is 4 ohm. The current in this branch is I. This is minus and plus. This is 2I. This is 4 ohm and this is 12 volt. Now in this circuit, when terminal A and B are open, we can find out open circuit voltage, that is VOC, and this open circuit voltage is nothing but VTH. And here there is a single loop. Apply the concept of KVL in this loop, then we can find out the value of, because there is one current I, then here here also the current is I. Since it is flowing in this direction, the plus and minus we can easily define. Now applying the KVL here, minus of 4 I, then minus, we are moving from lower to higher, it will be plus 2I, because this is a dependent voltage, current dependent voltage source, and whose magnitude depends upon this current. Then it will be, we are moving from higher to lower, then it will be minus 4I. We are moving from lower to higher, then it will be plus 12 is equal to 0. On simplifying this equation, we can have a, this is 4, this is 4, 8 minus 2, that will be minus 6I is equal to minus 12, and hence I is equal to 12 by 6 is equal to 2 ampere. In this branch, when this terminal A and B are open, the 2 ampere current will flow, and hence the VOC voltage across the terminal A and B open circuit voltage will be given as 4 into 2 is equal to 8 volt. VOC we have calculated. Now we have to find out the ISC. Now in this case, short circuit these two elements, two terminals A and B. Now in this case, let me consider the current is ISC, short circuit current. With this short circuit current, we can say we are having a two loops now. One loop is for this network and the second loop is for this network. Now here we consider the total current. Now in this case, the current in this branch will be I plus ISC, because I current is flowing in this direction, where I is flowing in this branch, and hence the total current in this branch will now be I plus ISC. Apply KVL. Now in this case, polarity is already marked as plus and minus. Then considering the first loop, it will be minus of 4 I plus ISC. Now plus or minus, we are moving from lower to higher potential, then it will be plus 2I. The polarity, the magnitude of this voltage source is 2I. Then moving from the another element, then it will be moving from higher to lower potential, it will be minus 4I. Moving from lower to higher potential, it will be minus of lower to higher potential, it will be plus 12 is equal to 0. This is for the first loop. In first loop, in second loop, applying KVL in second loop, this is loop 1, this is loop 2. In second loop, moving from higher to lower potential, minus of 2 ISC. Then we don't have element in these two branches, then we are having this element only, and from here my lower to higher potential it will be plus 4I is equal to 0. Rearrange this equation, we can find out the relation between I and ISC, and here 2 is, if 2 is taken as common, then it will be minus of ISC plus 2I is equal to 0, and hence ISC is equal to 2I, twice of I. Let's consider this equation is second. Putting second in this equation, then we can find out I. Now, after putting this value in I in this first equation, the value of I will be equals to 6 by 7 ampere. Now, since ISC is twice of this, then ISC will be equals to 2 into 6 by 7, that is 12 by 7 ampere. Now, in this circuit, we are knowing the value of ISC and open circuit voltage VOC. Therefore, RTH is equal to VOC upon ISC is equal to VOC is 8, ISC is 12 by 7, and then it will be equals to 14 by 3 ohm. This is 2, this is 3. Now, to find out maximum power, by the definition, we know the maximum power P max in any network is given by VTH square divided by 4 RTH. And RTH is 14 by 3, VTH is 8 volt, then we can find out maximum power, that is 8 square upon 4 into 14, then into 3, it will be equals to 3.43 watt. Answer. Now, considering another example, draw the equivalent network by source transformation and determine the current I in 8 ohm resistance. Now, in this case, we are having a three different current source, and this current source can be converted into equivalent voltage source by source transformation. By source transformation, the value of these sources can be find out. In this case, we are having a 3 ampere source and 3 ohm resistance in parallel, then it will be equivalent to 3 into 3, 9 volt, and in series with a resistance of 3 ohm plus minus 9 volt. This 6 ohm is already connected in the circuit, it remains as it is. Now we are having a source of 4 ampere in parallel with 4 ohm resistance, then it will be 4 into 4, 16. This is plus minus 16 volt. The internal resistance will remain same, that is 4 ohm. Now this resistance 8 ohm resistance is not going to be disturbed, and this is remain as it is. This the current in this branch is I. This is 8 ohm. Now this is 4 ohm resistance connected in series. Now, this is another combination of current source with parallel with 2 ohm resistance that can also be converted equivalent voltage source having internal resistance 2 ohm, and the magnitude of voltage is 10, 5 into 2. This will be plus, this will minus. This is 10 volt. This is 16 volt, 4 ohm. Now again we are having a two independent loop, then one loop is this, another loop is this. Because we have to solve this network by loop or mesh analysis, let's consider current in this branch is I1, in loop is I1, the current in this loop is I2. Now applying KVL in this circuit, apply KVL. Now starting from the first loop, since we have taken the direction of current is this, then it will be plus, it is minus, it will be plus, it will be minus. This is 6 ohm resistance. Now this will be plus, this will be minus, this will be plus, this will be minus. The polarity of source is already defined. It can be written as, this is minus of 3 I1, then minus of 6 I1, lower to higher, then it will be plus 16, then higher to lower minus 4 I1, then higher to lower minus 8 I1 minus I2. Since current in this element is the difference of I1 and I2, from upper side the I1 is coming, from downward the current I2 is flowing, and hence it will be I1 minus I2. Then we are having a source moving from lower to higher potential, it will be 9 is equal to 0. And on rearranging this equation, the resultant value will be 21 I1 minus 8 I2 is equal to 25. Let's consider this equation is first. Similarly, apply KVL in second loop. Now considering the loop 2, here it is loop 1 and here it is loop 2. In case of second loop, the current direction is already marked, then marking the potential across the elements, then it will be minus of 4I2, minus of 2I2, minus of 10 because we are moving from higher to lower potential, then plus 8 I1 minus I2 is equal to 0. On simplifying this equation, it gives 4 I1 minus 7 I2 is equal to 5. Let's consider this is equation 2. Now from equation 1 and 2, we can find out the value of I1 and I2. I1 will be equals to 1.173 ampere and I2 will be equals to minus of 0.0435 ampere. Now, since we know the current in this 8 ohm resistance is the difference of I1 minus I2, therefore I will be equals to I1 minus I2, which is equals to 1.173 minus of minus 0.0435, and which is equals to 1.216 ampere. This is nothing but answer. Now considering the another example, in this network we have to find out current through 10 ohm resistance I using nodal analysis. In order to apply nodal analysis in this network, first of all we have to convert this uh, equivalent network into voltage source. Why? Because converting this network equivalent to voltage source, it will make our calculation and process easy. Now first of all the conversion of this one is 4 into 20. Let's consider these are the two terminals A and B. This is A, this is B. Across terminal A and B we are having a current source and resistance. Then it will be like that, this magnitude of this source will be plus minus, that is 20, and the internal resistance will remain same 5 ohm. Connecting this value across terminal A and B, then the resultant network will be here we are having a resistance and a source across terminal A and B. This is the equivalent network, plus minus 10 volt. This is 4 ohm, this is 4 ohm, this is 5 ohm, this is plus minus 20 volt, this is 7 ohm, this is 10 ohm. Now in order to apply a nodal analysis, let's consider this is the reference node, and here there are two nodes. Let it is node A, let it is this node is B. At node A, the direction of current we can consider as, here it is I1, here it is I2, the current in this path let it is I3, and current in this path is I4, and current in this path is I5. Apply KCL at node A. We know KCL at node A will give I1 is equal to I1 I2 plus I3. Since the polarity potential between these 2 points is 10 minus VA. So if this node voltage is VA, if this node voltage is VB, then I1 will be equals to 10 minus VA, since we consider the direction of current is this, divided by 4. Then which is equals to the potential across this 4 ohm resistance is VA upon 4. The current we can find out I2. Similarly I3 in order to find out I3, the potential difference VA minus VB. Now in between there is a one more potential, and due to this potential current will flow in this direction only, and hence additive is the direction we considered, and hence it will be plus 20 divided by 5. If the polarity of this source was reversed, then we would have taken over here minus. This is the equation first, and on simplifying this equation we can have a resultant value as minus of 14 VA plus 4 VB is equal to 0. Let's consider this is equation first. Similarly, we can apply KCL at node 2, at node B, at second node. In second node, we know I3 is equal to I4 plus I5. This is I3. I3 we have already defined. This is the magnitude of I3, and hence here it is, we can write as it is VA minus VB plus 20 divided by 5 must equals to VB, because the potential at this node is VB and in between there is no source, and hence VB by 7, then plus VB by 10. Now on simplifying this equation, the resultant equation will be VA minus VB, this is 30. Now in this case, this equation will be on after simplification, it will be 14 VA minus 31 VB minus is equal to minus of 280. Let's consider this is equation second. Now using equation first and second, we can find out VA and VB. From equation first and second, minus of 14 VA plus of 4 VB is equal to 30. The second equation is 14 VA minus 31 VB is equal to minus of 280. From these two equations we can find out, this will be cancelled, minus of 27 VB is equal to minus of 250. VB is equal to 250 divided by 27, which is equals to 9.26 volt, and VA is in this equation we can accordingly find out, but here in this case we don't require VA. If we want to calculate, we can putting the value of VB in either of these equation, we can calculate VB. Since the potential across the 10 ohm resistance is VB, therefore current in 10 ohm resistance is VB upon 10, which is equals to 9.26 divided by 10, that is 0.926 ampere, and this is the answer. Now considering another example, in this case we have to find out the solution using star delta transformation. As from the circuit condition we can observe that these three elements are neither in series nor in parallel, but they makes if these 2 points are considered common, if this point is just common, and this is the third point, and hence we can say these three elements are connected in delta. However, we can also say 9, 9 and 6 ohm, these three elements are connected in star. Either we have to convert this delta into star, or this star into my delta, then it can simplify our problem. Now it is easy to calculate this star equivalent of this delta network because all the elements are equal, and hence we can apply the generalized concept of using R star is equal to R star is equal to resistance of opposite branch, that is R delta 1 into my R delta 2 divided by R delta 1 plus R delta 2 plus R delta 3. This is delta. And hence, since all the resistances are equal, it is 9 into 9 divided by sum of these three resistances, that will be 9 plus 9 plus 9. This is equals to 81 divided by 27 is equal to 3 ohm. And hence in this delta, when it is represented as a star, we can mark over here this is a star connection, and then remove the delta. Then the resultant network will become this is we are having one terminal here, another terminal in this network we will be having this another terminal, there is a resistance connected in between, then we are having a one resistance connected here, this is another resistance we are connecting over here, this element is now over, this is also over, this is also over. Now there is this resistance is 6 ohm which is connected over here, then we can say this is 6 ohm resistance, this is connected in series with this element, and finally we are having a one resistance over here of this is remain same, this is 6 ohm, this is 3, this is 3, this is 3, this is comes from conversion of delta to star, and this is 6 ohm resistance, this was 6, this is 5, this is 10, and this is 50 volt plus minus, these are ohms. Now in this case, now it will become a series parallel combination, and this series parallel combination can be easily solved. These two are in series and the series combination is in parallel with this network. Then this network can be reduced as we will be having a 3 ohm resistance up to here. Then this network can be reduced. This is 9, this is 9, and 9 and 9 parallel will give 4.5. 4.5, 3, 6, 5, 10, 50 plus minus. Now these two are in series and the series combination is in parallel with this network. Then the resultant network will become in second another step. This is this one. Then this combination will be solved as this is a 7.5, this is 6, this is 5, this is 10, this is plus minus 50 volt. Now further simplifying this network, it will gives us that is a source, more resistance here, we are having a 10 ohm resistance, then 5 ohm, and in series the combination is reduced to 3.33, this is 3.3, the parallel combination of these two resistances. This is series combination, the series combination is nothing 7.5, and this parallel combination will give 9 into 9 divided by 9 plus 9, this is 4.5. Now this is further, this is 50 volt plus minus, these two are now in series and series combination in parallel with 10 ohm resistance, and hence the resultant network from here we can have this one, this is the source, there we are having a 10 ohm resistance, then we are having a resultant resistance of 8.33, this is 10 ohm, this total so value of 50 volt, 50 volt, this 50 volt. Now by the definition, these two resistances are now in parallel. The parallel combination can further simplified, and parallel combination of this 10 into May 8.33 divided by 10 plus 8.33, that is RT, which is equals to 4.54 ohm. Now the applied voltage is 50, then the current supplied by the battery is equal to 50 divided by 4.54, which is equals to 11 ampere. And this is the answer. We have to find out the current supplied by the battery. The current supplied battery is current, let it is I. Now, considering another example, in this case we have to apply superposition theorem. Here we are having a three different source. This is a current source, this is also a current source, this is a voltage source. According to superposition theorem, we have to consider one source at one time. Let we consider 6 ampere. First we consider 6 ampere source, then the rest of the network is solved with other sources are replaced with their internal resistance. The internal resistance of current source is infinity. The internal resistance of voltage source is 0. The internal resistance of current source is infinity. The voltage source is 0. And hence this source will be replaced with an open circuit. This source will be replaced with an short circuit. Then the circuit will becomes like that. This is voltage source, it is shorted. This is current source, it is open. Now we are having a current source. Total current supplied is 6 ampere. This current is divided in two parts. Here it is 2 ohm, this is 3 ohm, this is 1 ohm. Simply applying the current division rule, we can calculate current in this branch. And because we have to find out voltage across this branch only, then we need to calculate current in this branch only. Let's consider I1 dash, the current flowing in this element due to this 6 ampere source. Let it is considered as I1 dash. The total current, it is given by multiplication of total current divided by into the resistance of opposite branch divided by sum of resistance 1 plus 5, that is equals to 1 ampere. It means the current supplied by 6 ampere source in this branch, it is 1 ampere. Now considering the second source. In second source we are having a current source again. Now the second source is considered. Here there is a resistance, and in this case we are having one resistance over here. There is a current source. This current source will be open. Then the another branch we are having a resistance over here. There is a voltage source. This voltage source behave like a short circuit, is made shorted. This is 1 ohm, this is 3 ohm, this is 2 ohm, this is 4 ampere. And now in this case we are having another equivalent circuit. This circuit can be represented as a parallel. These two branches are in series. These two elements are in series, and hence current supplied by the current source in this branch can also find out using a current division rule. Apply current division rule over here. This network can be redrawn as, then it will looks a simple network. Here it is a 2 ohm resistance, and here it is a 1 ohm resistance. This is 3 ohm, this is 4 ampere, this is 2, this is 1. Now we have to find out current in this branch. This total resistance of this branch is 3 ohm. This resistance of this branch is 3 already. We are knowing, then current, let consider I1 double dash due to current due to the 4 ampere source in this branch. Then we can find out total current is 4 into the resistance of opposite branch divided by sum of resistance is 3 plus 3, which is equals to 2 ampere. Now we calculated current due to 6 ampere, then we calculated current due to 4 ampere. Now we have to calculate current due to 6 volt source. Considering third, this is second source, this considering the third source. In third source, when all the other sources are replaced with their internal resistance, the equivalent network will be this one. This is open circuited, this is also open circuited, because this current source, this is a current source, this is a current source. This is 2, this is 3, this is 1. Now the source is 6 volt. Now we are knowing the resistance of this circuit is, we can find out current in this way because there is only one source. The direction of current can be this only, and hence I1 triple dash is equal to, this is 6 divided by 6 is equal to 1 ampere. Now it can be noticed here the current due to 6 ohm resistance it is downward, the current due to 4 ohm resistance it is also downward, whereas the current due to 6 ohm 6 volt source it is upward, and hence the total current I will be equals to I1 dash plus I1 double dash plus I1 triple dash. The current in due to I first source is 1 ampere, the current due to second source is 2 ampere, the current due to the third source will be minus of 1 ampere. Why minus is taken? Because this is opposite to these two rest of the currents, and hence the total current supplied by the source in this case is 2 ampere, and this is the answer. Now we have to find out the voltage across these two elements, across these terminals, that is V naught. Now in this case to find out V naught, since we know the voltage drop across this resistance is 2 into 2 because the current flowing in this resistance is 2 ampere and the direction of that current is given by downward, the resultant current will be downward, and hence this is plus, this will be minus. Now these two potentials are, we are moving from higher to lower, then the potential, if we want to find out polarity of this potential, then it V naught will be equals to 2 into 2 from, if it is plus and it is minus, then it will be minus of 2 into 2, then minus of 6, then it is equals to minus of 10 volt. If you want to find out this is plus and this is minus, then this voltage will be, sorry, this will be plus, this is 10 volt, and this is answer, voltage across this resistance. Now considering another example, in this case we are having a state of the switch at t is equal to 0 when the switch is made on. When the switch is made on, we consider here are two cases. One case is when there is a inductor is connected across these two terminal A and B. In the second case, when a capacitor is connected across the two terminal A and B. Let's consider the first case. In first case, case 1, when only inductor is connected across this network. Now the resultant network will be this one, it will be closed at t is equal to 0. This is the resistance, and there we are having an inductor. Now this is the resultant network when inductor is connected according to case 1. Here it is 100 volt at t is equal to 0. This resistance is also 100 ohm, this is 100 ohm, this is 50 ohm, and this is 300. Now by the definition we know initially if there is no current in the inductor behave like a short circuit. Now sorry, when switch is made on, inductor doesn't allow sudden change in current. Inductor doesn't allow sudden change in current through it, and hence initially if there was no current in this inductor and when switch is made on, there will be no current, and hence it behaves like an open circuit. Then the equivalent circuit will be this. At t is equal to 0, plus minus 100 volt, 100 ohm, 100 ohm, and hence the voltage in this path, we can find out current I is equal to 100 divided by 100 plus 100, which is equals to 0.5 ampere. The current in this element at t is equal to 0 is equal to 0.5, whereas current through this inductor IL is equal to 0, because inductor do not allow flow of current through it at with sudden change. Now, considering the second part, we calculated the current. Now we have to find out the voltage at current and voltage at infinite. When it is behaving like a open circuit, the voltage across the inductor will be the voltage which is appear across this element, because there is an inductor which behave like a open circuit. The voltage across these two terminal will be the voltage across this resistance, because there is no current in this 50 ohm resistance, and hence VL is equal to 50 volt. Half of the two resistances are connected in series, total voltage is 100, then it will be equally divided in 2, then it will be 50 volt. Now this second case, when we have to find out at t is equal to infinity. At t is equal to infinity, we know under steady state condition inductor behave like a short circuit. Inductor behave inductor behave as short circuit. Behave as short circuit. Then the equivalent network will be plus minus 100 volt. There is a resistance, another resistance is this, there is a resistance, and the inductor. This is 100, this is 100, this is 50. Inductor behave like a short circuit. Now we can find out the current flowing in these three branches this by simply applying the network reduction technique, and here these two 150 is in parallel. The parallel combination, the resistance of this parallel combination is given by the total current. The total current we can calculate supplied by the source I. I will be equals to 100 upon this parallel combination of these two in series with 100 plus parallel combination of 150, and it is equals to 0.75 ampere. Now we can find out current in these two branches. The current in this branch is 100 ohm resistance, and this current in this 50 ohm resistance by just simply applying current division rule. Then I100 will be equals to total current 0.75 multiplied by 50 opposite resistance divided by sum of resistance 150. This is equals to 0.25, and since total current is 0.75, in this branch current is flowing 0.25, then I50 will be equals to 0.5 ampere. This is the current. Now if the current flowing in this element is 0.5 ampere, then V across this resistance is V in this across this resistance will be 50 into 0.5, that is equals to 25 volt. The voltage drop across this resistance will also be 25 volt, because current in this resistance is 0.25 ampere, and hence if 25 volt is across here, the rest of the voltage will be here, that is the voltage across this 100 ohm resistance will be 75 volt. Here it will be 75 volt, and here it is. Now the voltage across the inductor is 0. In this case VL, voltage across inductor is equal to 0 because it behave like a short circuit. This is case 1. Now we are considering the case 2. In second case, considering the same network, the applied voltage is 100 volt. The switch is turned on at t is equal to 0. There is a resistance. There is one more resistance. There is resistance. Now across these 2 points a capacitor is connected. Now we are having a capacitor between the 2 points. Here it was 100 ohm. This is 100 ohm. This is 50 ohm. This is plus minus. Now when switch is made on, the property of capacitor is it doesn't allow sudden change in voltage. Capacitor doesn't allow sudden change in voltage. Therefore, whatever the initial voltage across this capacitor, the voltage will remain same at t is equal to 0 when switch is on. The initial voltage was 0 and hence capacitor behave like a short circuit. In 0 voltage means the short circuit. This is plus, this is minus. This is 100 volt. Now the switch is closed. There is a resistance of 100 ohm, another resistance of 100 ohm. There is a capacitor and capacitor behave like a short circuit at t is equal to 0, and this is 100, this is 100, this is 50, capacitor is shorted. Then we can find out current and voltage across each element. This case will become same as that of previous one, and hence the current in this element and current in this element we can find out, which is equals to, this is 0.75, this is 0.25, and this is point total current is 0.75, as we have already calculated in the previous case. This will be 50, this will be 20, this will be 25, this will be 0.25. This what we have calculated. It was, this is 0.25, this current was 0.5, was divided proportionally in these two resistances, and hence voltage across this 50 ohm resistance is 25 volt, whereas voltage across this 100 ohm resistance is 75 volt. Now this is the first case at t is equal to 0. Voltage across capacitor Vc is equal to 0 because it behave like a short circuit. Now we have to find out at t is equal to infinity. At t is equal to infinity, when capacitor is fully charged, when capacitor becomes fully charged, at that instant the circuit will becomes like that, plus minus 100 volt. Now this is made on at t is equal to, at t is equal to infinity we have to find out. Then this is a 100 ohm, this is 50 ohm. Then the circuit will be at, it will behave like a open circuit. Here it is 50, this is 100 ohm, this is 100 ohm, and now we are having a simply this circuit having a series the combination. Then the current flowing in this circuit I will be equals to 100 divided by 100 plus 100, which is equals to 0.5 ampere. Now there is no voltage current flowing in this path. In this current IC is equal to 0, and hence there is no voltage drop across this resistance. Now this is what we have calculated for currents and voltage. The voltage across these two resistances, it will be 50 volt and 50 volt. This is 50 volt, therefore another resistance is for 100 ohm it is 50 volt, and for this it is also 50 volt. Because total voltage is 100, it will be proportionally divided across these two. Now when capacitor is fully charged, then Vc infinity will be equals to the voltage across this element, and that voltage is 50 volt. Because when current becomes 0 across this element, then the current will flow through this path only, and the voltage will be divided proportionally. Then hence final voltage across the capacitor is 50 volt. The initial voltage across the at t is equal to 0 voltage was 0. Then we can write the generalized equation of Vct. Vct is equal to, Vct is equal to Vc infinity plus Vc 0 minus Vc infinity e to power minus t upon capital T. Now capital T, to find out capital T, which is equals to RC. What is the R of this network? In order to find out R of the network, we have to find out Thevenin equivalent resistance of the circuit when all the sources are replaced with their internal resistance across inductor and capacitor, then RTH. These two are, this is 100 ohm, this is 100 ohm. The voltage source, there was a voltage source which is converted represented as short circuit. This is 50 ohm. This the parallel combination of 100 and 100, it will be 50, and that this 50 will be in series with this 50 ohm. The total resistance is 100. Then R is equal to 100. RTH of this circuit is equal to 100 ohm, and therefore RC will be equals to, C is already defined, 3 into 10 to power minus 6 into 100. The RC will be equals to 0.3 millisecond. Whereas in case of inductor, the RTH will remain same. In case of inductor, R T is equal to L by R. L was given as 3 Henry and R is 100, and that will be equals to 0.03 second. In case of capacitor, the time constant is 0.3 millisecond, whereas in case of inductor, the time constant is 0.03 seconds. And hence, this is the resultant, and this is the answer, required answer.